Students, hi everyone. Today we are going to study how to find the eigenvalues for a 3 cross 3 matrix in an easy way. Okay. So we know how to solve 2 cross 2 matrix and find its eigenvalue and eigenvector, which I had uploaded in my last video. The details are in description box. Right. Now we are going to find a eigenvalue for a 3 cross 3 matrix. Matrix capital A is equal to 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5. We say this is 3 cross 3 because we have 3 rows and 3 columns. So finding the eigenvalue we have by characteristic equation, that is determinant of A minus lambda I. Using this you can find the eigenvalue for a 3 cross 3 matrix. So first let me explain with this concept of finding eigenvalue. I want you all to check the video till last so that you can understand finding the eigenvalue for 3 cross 3 matrix in an easy way. So please go till the last of video and check how to find the eigenvalue for a 3 cross 3 matrix in an easy way. So now let us start solving this matrix by characteristic equation. Determinant of A minus lambda is equal to 0. So take the matrix A 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5 minus lambda times, here we have 3 cross 3 matrix, so it is identity matrix of order 3 cross 3. So 1 0 1 0 1 0 and 0 0 1. Ultimately you need to find the determinant of this matrix. So I have taken the matrix as it is: 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5 minus, here lambda was multiplied, a scalar was multiplied with the identity matrix. So I have taken 1 into lambda lambda, the other elements are 0, again 0 into lambda 0. Lambda into 1 is lambda 0. Similarly 0 0 lambda. Now you have to subtract these two matrices. You know matrix subtraction is element by element. Okay. So you can say I have subtracted the element. 7 minus lambda minus 2 minus 0 is minus 2. 0 minus 0 0. Minus 2 minus lambda, minus 2 minus 0 is minus 2. 6 minus lambda is 6 minus lambda. Minus 2 minus 0 is minus 2. Again 0 minus 0 0. 2 minus 0 minus 2. 5 minus lambda is 5 minus lambda. Our next step in finding the eigenvalue, we need to find the determinant. So to find the determinant, we will start with the first element of the matrix, that is 7 minus lambda. So positive 7 minus lambda. Okay. So leave the corresponding row and column. The other minor elements you have to cross multiply. So it is 6 minus lambda into 5 minus lambda minus 2 into minus 2. So minus 2 into minus 2. So usually we will have the operation plus minus. So operations are plus minus plus minus plus minus plus minus plus. So here it is positive, second element should be negative, so it's minus, and your second element is minus 2. So leave the first row and the second column. The other element you take the minor diagonal. So it is minus 2 into 5 minus lambda minus of minus 2 into 0. And we have to go for the last element, which is positive 0. Since this element is 0, the product of that will also be 0. You don't have to write it. So I have just multiplied the inner term. 6 into 5 minus 6 into lambda minus 5 into lambda minus of minus plus lambda square. You have negative, so minus of minus plus 2 into 2 4. Minus into minus plus 2 minus 5 into 2 10, minus of minus plus 2 lambda. So you need to simplify. So on simplification we have lambda cube minus 18 lambda square plus 99 lambda minus 162 is equal to 0. So we have got a cubic equation. Why? Because since we have 3 cross 3 matrix, you will have a cubic equation here. So you can see we have taken so many steps to reach this cubic equation. As I told you, I will be explaining this in easy way. So instead of using a minus lambda I, you can use this standard equation for a 3 cross 3 matrix. Okay, for 3 cross 3 matrix. Okay, instead of doing all the step a minus lambda I hope you can see all this. Instead of doing a minus lambda I and then simplifying the terms and then getting back a cubic equation, instead of all this you can directly go for standard equation, that is lambda cube minus summation d. I'll explain what is summation d. Lambda square plus summation m suffix d lambda minus determinant of a is equal to 0. You can easily find the cubic equation for a 3 cross 3 matrix directly by using this formula. So I'll explain what is summation d, summation md. Okay. So after you know the standard form, okay, you should know what exactly the terms here. Lambda cube will not have any coefficient. It is 1. Okay. Lambda square will have summation d, that is nothing but sum of diagonal elements of a given matrix A. Summation d represents sum of diagonal elements of a given matrix A, and summation md represent sum of minor of diagonal element of A. You take all the diagonal. For that diagonal you need to find the minor value, and mod A represents a determinant of A. So if you know this equation and you know what this expansion, you can easily find the cubic equation for a 3 cross 3 matrix. So students, now we are going to understand by using the standard formula lambda cube minus alternate plus and minus sign, summation d lambda square plus summation md lambda minus determinant of a is equal to 0, and check whether the values what we have got in characteristic equation is it same with this notation, and this will be easy to get the answer than the characteristic equation. Okay, so for this lambda cube does not have any coefficients, it's 1, so we need to find summation d. As I already told, summation d is nothing but sum of the diagonal values. So here the diagonal values are 7 plus 6 plus 5, so totally it is 18. So with summation d is 18. Now we need to find the next value. So the next value is summation md. So summation md is nothing but you have to take the diagonal entries. What are the diagonal entries? We have 6, 7, 6 and 5. These are the diagonal entries. For this diagonal entries you need to find the minor and add it. Okay. So for 7 the minor are, so for 7 leave the corresponding row and column. The minor are 6 minus 2 and 5 plus the second diagonal is 6. So leave the corresponding row and column. Okay. So we have 7, 0, 0, 5. The last diagonal entry is 5. Leave the corresponding row and column. So we get 7 minus 2 and 6. So find the values. 6 5s are 30 minus 4 plus 35 minus 0 plus 6 into 7, 42 minus 4. So subtract it. So we get 30 minus 4 has 26. 30 minus 5, 35 minus 0 is 35. And we have 42 minus 4. So it is totally 38. Correct? Add it. You will get the answer 99. So this is the value for summation MD. So the last value we need to find is determinant of A. How to find determinant of A? Same matrix, you have to take the sign. So we have positive, negative, positive, negative, positive, negative, and positive, negative, and positive, right? So now I am going to take the first row, first element, that is 7. For 7, you leave the corresponding row and corresponding column. So what is the minor elements we have? Which is 6, minus 2, and 5. So next you have to take a negative sign, go for the second element of the first row, that is minus 2. For minus 2, take the corresponding row and column. The first row and the second column you have to delete. The other entries will be the minor, that is minus 2. So when I delete this, I have minus 2, 0, 5. Similarly, the last one, that is the third element of the first row, which is 0. So as you know, 0 into term becomes 0, so I am not writing it. You have to simplify. 7 into 6 5s are 30 minus 2 into minus 2 is 4. Minus of minus plus 2. Minus 2 into 5 minus 10. Minus 2 into 0 is 0 plus 0. Right? So we have 30 minus 4, which is 26. So 7 into 26 plus 2 into minus 10 is minus 2 tens are 20 is equal to 0. So 7 into 26 we get 182. Subtracted by 20. So your answer is 162. So this represents determinant of the matrix. So what you have to do now, you have to substitute all these values, summation MD, summation D and mod A to the standard formula. This is the easiest way to get the solution for a 3 cross 3 matrix. Okay. So when I substitute, I am getting lambda cube minus 18 lambda square plus 99 lambda minus, here it is 162. So 162 is equal to 0. You can verify this is the same answer which we have got using characteristic equation also. Just you have 3 steps, summation D, summation MD and mod A. If you are able to find, easily you will get a cubic equation. So once you have got a cubic equation, either you use characteristic equation or you can use the standard method. To find its solution, you can use the calculator. I'll show you how to use calculator here. Go to mod CLR, press 3 times. You will get an equation, that is number 1. Click number 1 and it will ask unknowns. Actually we don't have equations, a simultaneous equation here. We have only one equation with degree. So you can press this side. It shows degree 2 or degree 3. You can see our equation is a cubic. So I will go for degree 3. Press number 3. So when you do that, it will ask the coefficient value. See here, the coefficient of lambda's cube is 1. So I am taking 1 is equal to, next coefficient of lambda square, that is your second data, which is minus 18. Third data, lambda coefficient is 99. So I will take 99 for C value is equal to minus 162 is the last value. So it's minus 162 is equal to. So it will automatically calculate and give the value These values are nothing but the lambda values. So lambda is equal to 9, that is the first value. You can use this arrow, downward arrow mark, to get the other data. Lambda 2 is equal to 3, and use again the down arrow mark, and lambda 3 is equal to 6. So this is the corresponding eigen values. So here I have explained both by using characteristic equation and as well as by using the standard formula. So this is the easiest way to get the cubic equation quickly, and you can use your calculator to find its corresponding eigenvalues. I hope this method is clear to everyone. So in my next video I will try to upload solving the eigenvalues and eigenvectors by using numerical technique called Rayleigh's power method, where you will be finding the highest eigenvalue and the corresponding eigenvector. So thanks for your time and thanks for watching this video. Meet you in the next video. Thank you everyone.